equation 1 from the slope of the VT graph and equation 2 from the area under the VT graph. But now we're going to be using our linear systems of equation. So we're going to be playing the game of substitution, elimination, and so on that you learn in math. But we're going to try to keep it simple and only focus on substitution. Alright, so we're going to play a game similar to what we just did. But from equation 1, we're going to rewrite this expression in terms of V initial. So we're going to rearrange our equation 1. V initial plus A delta T equals to V final. So here we just flipped the terms from the equal sign. And we're going to isolate for V initial. So we're going to subtract both sides by A delta T. Or you can refer to this as moving to the other side. Now this is not a new equation. We just rearranged equation 1. So we call it 1 prime. And now we're going to substitute our initial velocity, 1 prime, into equation 2. So equation 1 prime was in terms of V initial, and we want to substitute it into equation 2, which had a V initial. And let's see, let's do the substitution. So the displacement equals 2. Now instead of V initial, we're going to write the one from equation 1 prime, which is V final minus A delta T. And the rest remains the same. So the V final divided by 2 times the change in time. And now is the fun part. Let's play the algebra game. So we're going to try to simplify this expression. Notice that we can collect like terms. We have V final, and those two are being added together, so that will give us 2V final minus A delta T, all divided by 2 times delta T. And this was just the displacement of Sonic, or our object. Let's do reverse expansion. It's not really called reverse expansion, this is still expansion. 2V final delta T minus A delta T all over 2. And in this case, like I mentioned before, delta T times delta T is delta T squared. Because the base is the same, we can add the exponents, which would be delta T squared. And as I mentioned earlier as well, generally in math, if you have A plus B over 2, you can rethink of writing this expression as A over 2 plus B over 2. Now the same thing will occur if instead of the positive or addition, we were doing subtraction. So the same thing. So we're going to be able to simplify our expression. 2V final delta T over 2 minus A delta T squared over 2. Now in this case, notice that we can cancel out the 2 to simplify our expression once again. Delta D equals to V final delta T minus 1 over 2 A delta T squared. This is it. That's our equation. So this is equation number 4. Again, not the most beautiful equation, not so memorable. But let's do something similar that we did earlier. And let's bring an equation that comes out of nowhere, which is our definition of displacement. So recall, delta D is the change in position, so D final minus D initial. So let's rewrite this. And now we're going to rearrange for D initial instead to be on its own. So D final, let's move the V final term and the acceleration term. And flip the equal sign. Now this to me is more beautiful, maybe not so easy to remember, but both are equally as valid. And this is just equation 4 in its alternate form, so we could call it 4 prime. But generally, you're always going to see it written as equation 4 in this way. So far in our story, we have 4 equations in motion, and you will think we're finished, but there's a big 5th one coming up. And after the 5th one, we're going to interpret these so that way they have some meaning and we can bring them to life, possibly with the help of Newton.